All right, let's take a look at a different transformation here. We have our basic function y equals 2 to the x, or in this case, f of x equals 2 to the x. This time we're changing it to 1/2 times 2 to the x, and we're going to look at what this 1/2 does to the problem. Okay, so in order to graph this, I'm going to set up a little t-table. I'm going to just sort of create a nice little xy table. And so I'm going to do x, and I guess I can call it g of x, although it's the same as y equals. So, this is the same as y, just like this is. So let's just do starting at 0 and sort of see where that takes us. And so I'm plugging into this 1/2 times 2 to the 0 because x, I'm replacing it with what x equals, 0. Well, 2 to the 0 is 1. Half of 1 is just a half. So I know that at 0, I need to be up 1/2. So I can see that this is a different place than the original one was. So 1/2 times 2 to the 1 power, the first power, right? When I go to the 1. So 2 to the first is just 2. Half of 2 is 1. So that means this is a coordinate 1, 1, just like the first one was a coordinate 0, 1/2. Okay, so at 1, I should be up 1. That's easy to plot that point. So now I'll do 1/2 times 2 to the second power. Well, 2 squared is 4. Half of 4 is 2. So now I'm at 2, 2. Okay, right 2, up 2. A new point. All right, let's do 1/2 times 2 to the third power. Okay, so 2 to the third is not 6. Be careful about that. 2 times 2 times 2, right? 2 cubed is 2 times 2 times 2, which is 4 times 2, which is 8. Okay, and I wrote a third here. Why did I do that? Oh, because of the 3, I guess. But the original says 1/2. So 1/2 of 8. Half of 8 is 4. So now my point is 3, 4. Okay, so right 3, I go up 4. This is forming a nice little curve. All right, let's do 1/2 times 2 to the 4th. That means I multiply by 2 again. So the 2 to the 4th is 16. Half of 16 is 8. And so I have 4, 8. So right 4 and up 8. Plot that point. All right, half of 2 to the 5th. And so 2 to the 5th is going to be the last one I just did, 16 times 2 more again. So 16 times 2 is 32. Half of 32 is 16. So my next point is 5, 16. So right 5 and up 16. Oh, okay. Getting quite the jump there, right? Interesting how this works. And then 1/2 times 2 to the 6th. So 32 times 2 is 64. So half of 64 is 32. So my last point is at 632. So at 6, way off the chart, right? It's going to be somewhere up here. Okay. So I could at least get several key points here that are going to help me. I can see that my graph is still approaching 0. Connect the points and try to make it as smooth a line as you can. And mine will not be very smooth. I'll just tell you that right now. You see that? That's so funny. There we go. And then I know it keeps going. All right. Pretend it's a nice, smooth transition. Yours will be better than mine. Essentially, this just gives us a chance to sort of see what happened to our graph, right? Because if we have to name this transformation, well, if we're not careful, we might say, oh, it's a translation. It's a transformation. It looks like a translation, which is just a slide, right? It just slid over, but it's not a slide. We don't have exactly the same thing here at the bottom, especially as I feel like I can see it the best. And so it's not just a translation, or it's not a translation at all. Remember, a translation would have come in up here or out here. This would have been a left or right translation, and this would have been a or down translation. And there's nothing there. There's literally nothing there. So there's no way that this is just sliding it around. And so that's not what we have. The difference from our original function here is that we have this 1/2 in front. And when you have that, you have what's called a vertical compression. It is called different things, but we'll call it a vertical compression. Sometimes you'll see vertical shrink. And that comes from this 1/2, this number being less than 1, that fractional part between 0 and 1 is going to sort of make this be compressed down. And so if you think of this blue graph as sort of a pushed down version of the original red one, right? Then that might help you to kind of think through that. So that's how you would describe it if you had to say what has happened here. There's been a vertical compression of 1/2. And then, your domain and your range are the same as they were to begin with. So the domain is all real numbers, and the range would be from the bottom to the top. And at the bottom, we're approaching 0. And then at the top, we're going to infinity, right? Like there's an arrow there that's just continuing up, right? So the domain is the all real numbers, and the range is from approaching 0 to infinity. And so our horizontal asymptote is still y equals 0 there. Okay. All right. I hope that's helpful to you. It can get tedious, and so stick with it. Keep trying. You can do it.